Hello again, this is Ahmed. Today we'll be talking about system sequence diagram, another agile modeling tool that we use. Um, Again, modeling is not for documentation. Modeling is not a documentation tool. It's more of driving the conversation among the team, have some sort of reaching shared understanding of what is it we're trying to build. And here we're getting a little bit into the design. In the other videos we talked about use case diagram, story map, specification by example. These are more into the analysis, requirement analysis side. So we use modeling for both analysis and design. Some of these models are static, some of them are dynamic, some of them, it's like a living document. Most of them you can go back and update them. It's just some of them has some static. They don't change more often, as we can see with others coming up. So system sequence diagram is when we take a user goal from the use case analysis. You can check the other video about that, and we start breaking it down into steps and find out the details of the interaction between the user and the system. In this, there are some notations. Again, it's a UML, very minimal notations. Again, the goal is not to document or create fancy diagrams. This is more to drive a conversation. Usually this happens, the team will collaborate into this. Here I'm just showing the tool. You can use it with your team. This is a tool that kind of not as commonly used as now as it used to be, but it can help you sometimes if you want to break things down and make sure that everybody's on the same page before we start coding or go deeper with other tools. We'll follow up with the same, continue with the same, simple example of the ATM. So this is the ATM side. You see that, the annotation, the name, you have a user here, and that will be a customer. Again, a little bit of notation. And more, this is a time-wise, and let's go with one of the things we did for the use case analysis was the withdraw cache, and you start putting the steps more. Remember, we did not do the login as far as our user activities. Our user activities need to be a one person, one place, and one time. So a user will not go in and log in and leave. So it will be this login. And I expect the information that we need to go with. It's the card and the PIN. So an arrow this direction is calling, and this is more of an endpoint here that we call an API or a function. Dotted or dashed, this is return, and we would do maybe this will return some sort of authorization. So this is a return value. In some situation, you can find out after a return value, I will call back and return more stuff. You can do that as well. Like for example, it would be you return a list of operations, like you wanna deposit, withdraw cash or what. Then here you would do, maybe I would do check balance. I pick the check balance. And I expect this to have some sort of an account information and maybe something about me as well as a user. This is again still higher level, not much details. Like user information can be sent, if this is an API, it can be in a header information or something like that. And I expect getting back some balance info. And this might be a data structure that we can break down later, and it has an amount, a currency, and what's not. Maybe as a user, I can do this multiple times. So there's that notation of a loop, and the loop, pretty much as long as the user want, I can check balance multiple accounts. Maybe I do that for every account. So this is as long as there is account, more accounts. So this is another notation. You do the loop in a box. All these steps will continue until this condition happen. Another example here can be maybe with more steps, would be the withdrawal in cache. So after you do the login, and you do one of these system diagrams for each of the user activities that we identified in the use case diagram. And sometimes we write this here. So this now is withdraw cache. We didn't write it the first time, but usually this is the label of this. It's for withdraw cache activity, and these are the steps for it. So for this one would be maybe get cache. We notice that each of these names are as a verb or an action, a verb, a noun, or an action. It's not like cache withdrawal. It would be withdraw cache or get cache. Just a notation to keep that more into the action activities. So if you get cache, I want from this account and maybe amount. This will return maybe okay. Can or enough fund. Funds are available to withdraw. You would do after that, and okay, I want to confirm the amount, confirm it. Amount. You get some sort of a confirmation message, and this would be dotted. Or we decide that, okay, when I get cache, I get enough or okay, and I do not need to make another call. It gets followed up with that confirmation. For now, we'll assume that I will do confirm here. Amount. You still have the account and amount. When you get the confirmation, again, for this, I can add a loop into it, but let's finish what will happen for one deposit now. Usually you would have, I get a confirmation that it's done. I get asked, you pull the card. So how this will notify the system that the card is pulled, the user has pulled the card. So you have some sort of an interface in the system or the machine that actually doing this, and then you get money. Dispense the money, and again it needs to be dispense money, and you have the amount, and so on. You would go more further to find out, do you need a receipt or not? At the end, you have another activities. You want to do another transaction, and you start using this loop. So I will box this in the loop. More transactions. And again, this is just a notation to help us to break down, imagine exactly what are the steps, just mainly to make sure that everybody, have the same understanding of what we're building. We're designing together, collaborating, having a conversation around it. The visual aspect of it, as in any other modeling, help us, with the collaboration. Low fidelity. Once we agree on it, we know that now these will be more of an endpoint functions, and these are data types sometimes. But we'll see this how we'll take the system sequence diagram and move forward toward other activities. That's it for system sequence diagram. Again, this is a simple example. Maybe after I'm done with doing an end-to-end with the ATM, we can think of more complicated examples and do it. Again, these are not something that you would do on your own. If you're the architect, you don't just sit by yourself and do this, or a tech lead or an engineer. If this is not done with a team, it loses the main purpose of it, that we're putting our head together and sharing our ideas, and at the end we have an idea what we're building. It's a very effective tool as far as collaboration and reaching that common understanding for it. So don't do this in your own. It needs to be in a team. I'm doing this to show the steps and how it feels. Maybe someday we would find volunteers and we do an actual example and record it for you guys as well. For now, I will leave you with this, a system sequence diagram, and I will see you in the next video.